Welcome everyone to this amazing question, which is not very difficult but definitely very challenging question. Here given is a circle and a quadrant intersecting at point E. Now this point A of the quadrant is joined to this point of intersection here, and they are passing through the center of the circle. Now the second line segment is drawn from this center of the quadrant to this point E here, intersecting at this point here, and the third line segment is drawn from point A to this new point of intersection. Exciting part is with this limited data, we have to find this blue shaded region here. Let's check this amazing solution. Let's start by drawing the radius of the circle, that's OC length and OB length. Now this blue region, that's nothing but area of segment, and area of segment is given by area of sector, that's OBC, minus area of this triangle OBC. Now if we'll assume this angle O here is theta degrees, then area of sector, that's given by formula theta upon 360 times pi r square, where r is the radius of this red circle, and area of triangle, that's given by half of AB times sine theta, where A and B are the side lengths containing this angle theta, and here these side lengths are r centimeter. So triangle area is half of r times r sine theta. So to get our answer, r is already given as 2 centimeter. So what we need is angle theta here. Now we have to do some angle chasing here. So this angle theta we can find if we can get value of this angle C or angle B here. Angle B and C, these are equal because these are angles opposite to equal sides. So let's find value of this angle C here. For that, let's complete the quadrant into a semicircle and let's join EF here. If we'll assume this angle is alpha degrees, then this angle here, look carefully, PF and PE, these are the radius of this semicircle. So it's an isosceles triangle. So this angle will also be alpha degrees. Now AF is the diameter. We know diameter always makes an angle of 90 degree at the circumference. So this angle E here is 90 degree. And this remaining angle, of course, that will be 90 minus alpha. Now again look carefully, this triangle EOC, in this OE is radius, OC is also radius, and thus it's an isosceles triangle, and this angle here, that will be same 90 minus alpha, and by angle sum property this angle will be 2 alpha degrees. Now in this yellow triangle, if you look carefully, this angle is exterior angle, and exterior angle is always equals to sum of interior opposite angle. So this angle here is 2 alpha degrees. Now you must be amazed what we are doing here. Now if you look carefully, the magic is happening here. This quadrilateral, it has got one angle as 2 alpha degrees, and the opposite exterior angle is also 2 alpha degree. So by theorem, a quadrilateral in which exterior angle is equals to interior opposite angle, it's a cyclic quadrilateral. So we have proved this OCPA is a cyclic quadrilateral. Let's remove all other things at present. Now in this, from point O with respect to this circle, let's drop a perpendicular down below on the tangent AP. And from point O, let's drop a perpendicular on this tangent DP here. Now this figure is a square and OP is the diagonal, and we know that in a square, diagonal always makes an angle of 45 degree with the side length. So this angle is 45 degree. Now AO is a chord with respect to this blue circle, which is making an angle of 45 degree at the circumference. Now by angle in the same segment theorem, the same chord AO will make angle of 45 degree at point C. So this angle here is 45 degree. As angle C is 45, angle B, that will also be 45, as OB and OC lengths are equal. and this angle theta, this will be 90 degree. And our blue area, now we can put theta is 90, so blue region will be 90 upon 360 times pi r square, where r is 2 centimeter. Area of triangle, this is a right angle triangle, so it will be half of base into height. Simplifying it, we'll get this blue region as pi minus 2 centimeter square, and that's our answer. I hope you enjoyed the solution. I will see you in next video. Till then, tata, bye bye.